I'm Anil Kumar, and in this video we are going to learn a couple of things. One is how to write standard form of an equation in the vertex form, and then how to read that equation, and finally how to sketch a graph of a parabola using that vertex form of the equation. Now this is a very important aspect, and most of the time we are doing this to sketch the parabolas or even to write transformations from a given quadratic equation. So let's begin by writing the equation itself, which is y equals to x squared plus 6x plus 8. Now the first step always is to work with the first two terms of this quadratic equation. Keep that constant away. Now here the coefficient is 1, so we do not have to factor any number. So the next step, which is normally the second step, is we have to find half of this number, which is the coefficient of x, add and subtract its square. So when you do that, you get x squared plus 6x. Half of 6 is 3, so we'll add and subtract 3 square, and then we'll write plus 8. So this is our always the step, very important step. So what we do at this step is we'll actually find half of 6, right, and square it, and then add and subtract the same number. So when you do addition subtraction of the same number, you're basically adding a 0. That really does not affect the equation. The equation still is same, but it brings in a major change. That is, these three terms become a perfect square, and they can now be written as x signed from here, the number 3 from there, whole square. So if you expand it, you get x squared plus 2 times 3x, which is 6x, plus 3 squared. Do you see that? So that is completing the squares. I hope the name suggests how a technique used to complete the squares, right? So these three terms of this trinomial can be written as a perfect square, x plus 3 whole square. Now the other two constants can be combined, so we have minus 9 plus 8. So now I can write this as x plus 3 whole square minus 1. So we have a quadratic equation in the vertex form. This is what is called vertex form. Reason is that from here you can directly read the vertex, right? Now we can write from here that the vertex of our parabola will be minus 3. Minus 3 will make this 0, and minus 1. So the x value is minus 3, y value is minus 1, correct? So when you say find vertex of a parabola, then write the equation in the vertex form, and from there you read the vertex. There you are. Now let us do, so we have already done this. Now let's do the second part, which is sketch the graph, labeling vertex, axis of symmetry, and two other points. So the vertex is minus 3, minus 1. Each unit, let us say, is 1 for us. So each unit is 1 for us, okay. Minus 3 means 1, 2, 3 on the negative side, and minus 1, 1 unit down. So that is the vertex for us. Minus 3, minus 1, correct? Now, we will label it. It says axis of symmetry. Axis of symmetry is always the x value of the vertex. So axis of symmetry is x equals to minus 3. You can sketch it by a dotted line, vertical dotted line, I should say, kind of like this. So let me label it now. So this is our axis of symmetry, and the equation is x equals to minus 3. And here we have the vertex, whose coordinate points are minus 3, minus 1. Correct? Now, and two other points on this parabola. Now to sketch the parabola, we can follow a pattern. So whenever we are sketching a parabola from the vertex, we can follow the steps. The steps normally are 1, 3, 5, 7. Now, since this coefficient is 1, they will remain 1, 3, 5, 7. What does that mean? It really means that since we know this is axis of symmetry, if I move 1 unit away to get the next point, I have to go 1 unit up. So 1. Next time if I move 1 unit away, I have to go 3 units. These are the steps. 1, 2, 3. So that's the next point. And then if I use 1 unit away, 5 steps. 1, 2, 3, 4, 5. So these are my 5 steps, correct? Now let me extend this axis of symmetry. Since this is axis of symmetry, all the points will be symmetrically aligned, right? So this is axis. So let's find mirror images of these points to get other points, right? So this is 3 away, 1, 2, 3. So we get these points with us. Joining these points, we can actually sketch the parabola. Whenever you sketch your parabola, don't make a corner here, right? So make a kind of like this. Do you understand? A smooth curve and followed by an arrow. Since it is extending, the domain of this is all real numbers and range is greater than equal to the vertex point, correct? So that is how you get your parabola. Now it says 2 other points, right? So from this we can find 2 other points. First point is this, our x-intercept, for example. So this point is at, since this is minus 3, this is minus 4. So this point is minus 4, 0. The x-intercept. Of course it has a mirror image, minus 2, 0. But let me give you next point as this one, which becomes the y-intercept for us, which is at 1, 2, 3, 4, 5, 6, 7, 8. So it is at 8, right? You can always verify this answer. If I write x as 0, you get 8. So that clearly shows that our sketch is correct. Is that okay? So 8 is your y-intercept and it is always a good point to show on the graph, correct? So we have 0, 8 as the second point, right? So I'll choose to show x-intercepts and y-intercept as my other 2 points, correct? So I hope with this you understand how to apply completing the squares method to find the vertex of a parabola, and once you have it in the vertex form, how to sketch it using the vertex and the steps, correct? I hope that helps. I'm sorry. You can subscribe to my videos and learn a lot. Thank you and all the best.